Climate change and rising global temperatures increase the severity and frequency of wildfires globally. And as seen in Australia, bushfires have caused destruction in homes and fatalities to both humans and wildlife. Timber is a renewable resource that is popular in construction, but for timber structures, our homes, for example, without protection, they can be easily ignited in a fire. So in order to make it so that the homes that we build are both sustainable and suitable for bushfire-prone areas, passive fire protection systems are needed. But the question is, how do we protect our homes sustainably from bushfire? One of the areas that we can look into is using industrial waste. Coal, for example, is responsible for the largest global electricity generation. And in fact, in Australia, coal generates 60% of the electricity used to power our homes. But it is known that the extraction and burning of such fossil fuel contributes to greenhouse gas emissions. Because it is widely adopted, are there any ways that we can offset its environmental impacts? It is important to realize that fly ash is a waste byproduct from coal combustion, and it accounts for almost a fifth of Australia's entire waste stream. And it generally goes to landfill as waste without any further use. So what can we make out of such industrial waste? The solution is we have developed facade systems using fly ash, firstly, and multiple other industrial wastes. And these waste materials are formed into panels that are resistant against fire. Additionally, we have also developed a novel foam, the CRK foam, for use as replacement of traditional heat insulation foams, such as EPS. This is due to the known sustainability issues regarding the petroleum resources harvested in order to manufacture these traditional heat insulation foams. So the next question is, how well do the materials in these facade systems perform in a fire? We have conducted fire-resistant tests according to the Australian standards, where we expose the exterior surface of our material to high temperatures and we record the temperature on the interior surface to see how well heat penetrates through it. And results show that when we expose the exterior surface of our panels to 850 degrees, the interior surface reached only 60 degrees after 30 minutes of exposure. And when we exposed the CRK foam to the same conditions, it was found that the interior surface reached only 90 degrees after 30 minutes of exposure. Ultimately, the main aim from using these two materials in our facade system is to firstly showcase the low environmental costs of our materials since waste was utilized, but secondly, to also show that we can develop facade systems from which are capable of preventing the loss of lives as well as the destruction of homes from bushfire. Thank you.
It's very good because bushfires is very common, and I think we can expect, hope not this time, but in about the end of January, February. So we all are really nervous at that time. So no, thank you very much for that presentation. Any questions online from the audience here? Or maybe I'll just ask. I know this is Professor Kate Nguyen was here. She's supervising your project, right? It's here. So she was here in the morning, and she said she had some fire tests to be done today with some international partners. So, so it's a very good project. So, what is your thinking that you are looking at the BRL levels with the bushfire rating levels? Yep. So you are looking at some timber used in those bushfire areas, or you're particularly selecting some timber structures? So
we're not looking into any sort of timber species in general. Our aim is to develop this facade system that its main objective is to fix into timber framing and to protect those timber structures from bushfire, essentially.
Thank you very much. And Elena, you also interested to know instead. So you like to ask something, or?
I had a question in relation to the ambers. If you had your research has gone to that stage where how would the material behave if ambers will get trapped in the joints? Because that's probably the highest risk.
Ambers from the fire getting trapped in the joints. So we haven't looked into that specific area. So what we have done so far is conducting bench scale tests, which is small scale tests of these materials and how they perform. And you can see, as I've described in the presentation. So we haven't really looked into the ambers in general, but But our plan in the future is to also conduct a full scale, which is a representative scale assessment of which is full scale fire test. And we're going to look at, how the facade itself perform in the fire. And hopefully in that stage, we will look into, in that specific area.
Through practice, you've noticed that that's probably the highest risk.
Yeah.
Through practice, we've noticed that that's the highest risk for these dwellings fail in those particular areas. So they may be, behaving quite well in test format, but for instance, so the subfloor, so the subfloor areas are high risk because the fire comes from, especially if they're suspended and the subfloors are not enclosed. So there's particular. So as an overall, they may pass the test very well, but when you go into the specific areas of, the subfloors or joints or specific timber members, there's, particular risks that, could create a disaster.
So yeah, I just want to know something. So in a bushfire, it is, there are three main mechanisms of, attack on our dwelling essentially. So what we can expect generally is radiant attack, which is the radiant heat from the fire itself, from the ignition source. But as you mentioned, amber attack is also one of the main attacks on our system. But we haven't really looked into that specific area. But it is certainly one of the main attack mechanisms in a bushfire.
Thank you very much. I think I'm sure it's for another PhD as well, but maybe we can pass the message. And thank you, Elena. Elena runs a very important company working on a number of projects. So I think good to interact. And Dr. Kasman Shana is the main CI from the TREMS for this particular project. So I'm sure we'll interact with him for that. Thank you very much. Very good press. There's another question.
I think there's one more from the audience. Have you done any ICA analysis? I'm assuming that means, is that? LCA analysis.
LCA. Yep. So it's actually in the works. It's one of my thesis chapter to conduct a life cycle assessment on how facade systems perform in application compared to conventional facade systems. It's actually being run right now, so I'm currently working on it. It's a thesis chapter that I aim to complete sometime in the next few months, hopefully. Yep.
Thank you very much. I think, thank you. Very good presentation and wish you all appreciation.